Hi. Okay. So this is the fifth time I have tried to record this lecture. So I'm feeling a little crazy right now. So hopefully we can get through this. We're going to talk about Unit 1, Section 1.5, solving inequalities. And I expect that you have already seen how to do this and that this is going to be very much like a review. Okay. So let's get started. Hopefully, I can make it through this. If not, I don't know what I'm going to do. Okay. So we're talking about inequality equations, right? So with a regular equation, when you're dealing with an equal sign, you're going to have the number of solutions that correlate with the highest power of x in your problem, right? If you have just x, you're going to have one solution. If you have x squared, you're going to have two. If you have x cubed, you'll have three, and so forth. Okay. Now, when you're dealing with inequality equations, you don't get an answer, you get a range of answers. Okay. And that range of answers has to be given in interval notation. All right. And the notation really matters, whether you use a parenthesis or a bracket, that really tells us a lot of information. Remember that parentheses are up to, not including, and brackets are up to and including. Okay. Oh, geez, y'all, this day. Okay. Up to and including. So, made you a little reminder over here. If it is greater than or less than, you use parentheses. If it is an infinity, you use parentheses. And if it is an equal to, greater than or equal to, less than or equal to, you use a bracket. The way I always remember it is if my inequality sign has got a line underneath, then I'm going to have to use those lined parentheses, also known as a bracket. Um, Another thing that you're going to notice in your homework is some of the questions ask you to graph the solution set. Okay, now I'm not going to ask you to graph the solution set on an exam. That's just a way to make sure that you're putting together the visual with the abstract, writing out the answer in interval notation. But I'm sure you have done that before. So the answers have to be in interval notation. And I have some examples here, say after you've done your work, like how do you write your solved inequality into interval notation here. This first says x is greater than or equal to 2. All right. And so if we were going to draw a little number line with this going infinity, this negative infinity, and I just threw a 2 on here, then if I wanted to draw this, I would start with a bracket at 2 and I would go on with an arrowhead pointing towards infinity, indicating that it goes on and on and on. I'll grab this other one down here. So if I had 0 and 10, this being infinity and this being negative infinity, this one right here says that we are going to include 0, but not include 10. Okay. But again, what I really care about is just the interval notation. All right. Doesn't matter to me if you need to draw it or not. Okay. All right. So let's get to solving our inequalities. Just like when you solve an equation, you first definitely want to look, can I clear out any fractions and make my life easier? You definitely want to do that. Are there any parentheses that I need to clear out before I can solve this equation? You want to go ahead and do that. But from then, you want to isolate your variables on one side and your constants on the other. Now, in this case, because we're talking about inequalities and the direction in which your inequality sign points matters on writing the answer, I'm going to suggest that you definitely go to the left with your variables. That way you can avoid any solution confusion. And what I mean by that is, say you worked it out and you wound up saying this. That was what you wound up with. Okay, it has been my experience that a lot of times students don't pay attention to the the order in which the equation is, but they pay attention to the direction of the inequality and what number it is, right? And so a lot of times I will find that someone will write 5 to infinity because this is greater than, and they see the 5. Okay, that is wrong. You really have to have your variable on the left so you read it correctly. And so this actually is x is less than 5. And the actual answer is negative infinity to 5. So it really does help if you put all your variables on the left-hand side. It just keeps you from having to think about something more when it comes to finding the solution. There's also another very, very important thing, and I even wrote that it was important. I'm going to highlight it. When you divide or multiply by a negative number, the inequality flips over. So in other words, if it was greater than, it goes to less than. If it was less than or equal to, it goes to greater than or equal to. It just flips that sign over to its opposite sign. And then, of course, we're just going to go ahead and solve like we have always solved, whatever the technique is. I don't really think that you guys are going to come across any true quadratic inequalities yet. I think that is something that we do in the first unit in pre-calculus. But either way, and then you want to also express the solution in interval notation. So let's get to our first examples here. Okay, so the first example here is 3 minus 2x is less than 5. So note here we're going to be using parentheses here, right? No brackets at all because it is not equal to. And then we're going to solve this just like this inequality was an equal sign, okay? So first things first, we want to move all the constants right and all the variables left. So I'm going to subtract 3 from both sides. We're going to get negative 2x is less than 2, and then I need to divide both sides by negative 2 to get the x by itself. So I get x is, and this is where I flip over my sign because I divided by a negative number. And my interval is x is greater than negative 1. So my answer is going to be negative 1 to infinity, all in parentheses. Okay. Alrighty. Next one, I'm going to get all my variables left, all my numbers right. So I'm going to subtract 4x from both sides, and I'm also going to add 3 to both sides. And so we wind up with negative 2x is less than or equal to 10. And again, here we have this negative 2, so we're going to divide both sides by negative 2, and that's going to give us x is greater than or equal to negative 5. So our interval here is going to start with negative 5. It always goes smallest to biggest and goes to infinity. We have a bracket on the negative 5, and we always gently hold our infinities with curved parentheses because we can't get to infinity. Okay, So let's get to a combined inequality. This is the sandwich case, and I really like these problems, but I hate teaching them online because I can't really do what I do in the classroom, which is cover over one side of the problem. So let's look at this problem here on the left. We have -5 less than 3x less than 2 minus 2 less than 1. Okay, so -5 less than 3x minus 2 less than 1. Now, we have kind of two equal signs here. This is a three-sided equation. And when you have a three-sided equation, the thing you have to do is whatever you do, you have to do to all three sides. Okay? So when we look here at this problem, and remember that the idea is to isolate the variable, okay? That means we move everything away so that the only thing left in the middle is just x. And we always move addition and subtraction first and then divide last. That's always the way when we solve linear equations. So let's add 2 to all three sides, okay? -3 less than 3x less than 3 is what we wind up with. Now the x is not isolated yet. We need to divide by 3, and what we do to that guy, we do to all three pieces. And now we have -1 less than x less than 1. We didn't divide by anything negative, so no need to change any, flip any signs, do anything heroic there. Just time to write the answer in interval notation. Awesome. Okay, so let's give this one a little you do action. Okay, now the first thing you do want to do is clear the fractions. We'll multiply all three sides by the LCD. And the LCD should be really easy to come up with because there's only one denominator, so there's only one option. Okay, so I'm going to give you a couple minutes here. And as usual, you can pause the video and finish the problem, right? And then start the video back up and check your work. That's a great thing. Be sure you're doing that. All right, I'm going to get going here. The LCD in this case is 2. So I'm going to multiply everything by 2. And multiply this guy by 2, this guy by 2, and this guy by 2. So we wind up with -2 less than or equal to, these 2's cancel, and we're just left with a 3x minus 5 less than or equal to 18. Cool. Let's keep on going. Adding 5 to all three sides. We're left with 3 less than or equal to 3x less than or equal to 23. We're going to divide everybody through by 3. We're left with 1 less than or equal to x less than or equal to 23/3. And our answer. Okay. Yay. Okay. I hope you did good. All right. Well, we're going to end this. All right. I think I have one more I want to do. I know I have one more I do. I have one more I want to do that is not written up on this, that I wrote in my notes. And I need today's silly phrase. I almost forgot that too, even though I put a little sticky note right here on my computer. So today's attendance phrase is my shadow arrived late. Okay, the attendance phrase, my shadow arrived late. All right, let's do this other example that I'm just going to write in here. And I think you'll appreciate this. I noticed that I didn't do any like this, and I know I assigned you some homework like this. So, oops, it helps if I write the problem down, right? Now, let's remind ourselves what negative exponents do. Okay, so I'm going to come over here just a little bit. Let me grab this and let's remember what negative exponents do. All right, so if I have a to the negative 1, that is equal to 1 over a to the 1 power, right? So what negative exponents do is they force a fraction. In other words, remember that everything, let's just think about it like this. I have 2x minus 3. Everything has a denominator, even if we don't see it, right? Everything has a denominator of 1. Okay. So if we have something that is raised to the negative power, doesn't have to be -1, it could be negative anything. I'm going to say -2. Then what that means is that negative exponent means that you change positions in the fraction. So this is now equal to 1 over 2 minus 3 squared on the bottom. So that's what the negative exponent does. All right. So let's get back over here to our example. So the first thing we need to do is clear out that parenthesis, and doing so makes us do this. 1 over 3 minus 5x greater than or equal to 7. Cool, right? Okay. Now we can never solve for a variable in the denominator. Now, I don't know, I should say that a million times, but you can never, and there's not a lot of nevers in math. I surely don't say a whole lot of nevers, but you can never solve for a variable in a denominator. It doesn't matter how much math you know, okay? You still always got to get everything up out of that denominator. So how do we do that? We clear the fractions by multiplying through by the LCD. Yes, LCD. And here our LCD is 3 minus 5x because that's the only denominator we have. So we're going to multiply this side by 3 minus 5x. And we're going to multiply this side by 3 minus 5x. So that's going to give us 1 is greater than or equal to 7 times 3 minus 5x. Now I'm going to rewrite this. This is 7 times 3 minus 5x, keeping the pointed end at the 7. That way you're sure you don't screw up, and writing the 1 there. Now I have my variables on the left-hand side. And I'm going to finish solving. 21 minus 35x less than or equal to 1. Subtracting the 21 from both sides, we get negative 35x less than or equal to negative 20, dividing by the negative 35. We have x is, changing my color, greater than or equal to, it flips because we divided by a negative, and then let's see, 4/7. So our answer here is x is greater than or equal to 4/7. So we have 4/7 to infinity. So sorry I missed that on the slides, but I'm glad I noticed it and threw that problem in there for you. Okay, let's hit up an application problem. Surge pricing. Surge pricing occurs in our economy, and the phenomenon can be demonstrated by looking at Uber. One customer traveled 23 miles to the airport at different times and on different days and recorded his last 5 trips. The separate trips cost $20.93, $28.23, $40.44, $22.67, and $34.55. What is the range of cost per mile for the 5 trips? So basically, they wanted us to give them an interval of the lowest cost per mile to the highest cost per mile. So let's see, we're looking for. So in setting up the interval, we need the lowest and the highest. That's what we're looking at. And so how can we find out the cost per mile? Well, I'm going to take the lowest cost. Why everything's just acting just a little bit weird. Okay, I'm going to take this lowest cost and I'm going to take the highest cost and I'm going to figure out the cost per mile on those. Okay, so for the low, 20.93 divided by 23, right? Because that tells us what that cost per mile is, and that's 0.91 cents. And then the high, it's going to be that highest price, that $40.44. You know you were mad when you got that bill. You're like, what the heck? It's usually around 20 bucks. And when you do that math, you get 176. So our range is going to be from, because we've actually paid these, I'm going to use brackets. And there is the range of cost per mile will be between 91 cents and $1.76 per mile. All right, cool. And I think we have one more. We do one more, and then we're done. Feels like I've been teaching this class for hours because of all the failed attempts. I'm super happy that it's happening now. Last one, let's go. Okay. Suppose you got a small McCafe shake that has 14 grams of fat, a quarter pounder with cheese with 26 grams of fat. How many chocolate chip cookies that have 8 grams of fat in them can you eat and keep the fat grams under 64 grams of fat for your meal? Okay, so how are we going to do that? This is definitely an inequality because it says under 64 grams. So we know we're going to have all that crap has to be less than 64 grams, not less than or equal to, but less than 64 grams. And so it's like, okay, so we got 14 grams already ingested, 26 grams already ingested. The question is, how many cookies can we eat? So our equation here is going to be 14 plus 26 plus 8 times x, x being the number of cookies. Okay. And now we've got a nice little inequality problem. Pretty straightforward. Let's see here. 6 and 4 is 10. So we have 40 plus 8x less than 64. Subtracting those 40 over, we got 8x is less than 24 divided by 8. X is less than 3. So you can eat 3 cookies to keep your so you can eat 3 cookies and keep the meal under 64 grams of fat. All right. Oh, y'all, we did it. I feel like I should celebrate making it through this. Okay, you have a great day.